and welcome to my diabolical laboratory. My name is Candice and Moraga, and I'm here to conduct an experiment today on the caloric content of food. Now, as we can see here, I've got a few scrumptious little snacks out, including potato chips, marshmallows, walnut halves and pieces, and I've got some Orville Redenbacher's popcorn. I think I may just eat that right now. And I already did some calculations where I set aside this particular potato chip that I'm going to be using. And this walnut is really big and should be pretty awesome. And then this marshmallow here, now I'm starting to wish that I had gotten like jumbo marshmallows, the kind that you make s'mores out of. But anyways, basically with this lab, let me explain what we're doing today. We know that the specific heat of water is 4.184 joules. I don't know if you can see that from there. But basically, in our lab on caloric content of food, just to explain calories, 1 calorie is what takes away 1 gram of water, 1 degree Celsius in temperature. Now the calories, the nutritional calories that we normally see on the back of our packages are actually 1,000 of the calories that I'm talking about, calories with a little c, as opposed to the nutritional calories, which is calories with a big C. So we've got this formula. I'm going to be doing a bunch of calculations to compute the caloric content of these foods without peeking at the backs of the packages. And I think all these, all those definitely have some good amount of calories to them. So it should be fun to do. And this basically is our equation we know as MCAT. Q equals MCAT. But actually, Q stands for heat energy in joules. M stands for mass in grams. This C with a little s here, it stands for the specific heat. There's different specific heat of different substances, but we're going to be using water in our beaker today. And then we've got delta T here is actually a change in temperature, a difference between the final temperature and the initial temperature. So how I'm going to find the caloric content of this food is through a process called calorimetry. And basically what I did was I already measured out some masses here on my little electronic scale. I've got an aluminum tin here with a little metal stand so I can burn things. And I've got 50 grams of water in here, and I've got a little thermometer which I've measured the temperature of the water. Well, I guess it's changed temperature in here. I had the AC going, so it was 20 degrees Celsius before, but I'm going to put, I think we're actually, I must have really been blasting that AC. It's really more at like 16 degrees Celsius. I've got, I've weighed out, I've got some forks here that I can hold things with, and I've got this little test tube holder I'm going to use for the nut because it can take the nuts a while to burn. Mass of beaker, I took some computations of that, and then the mass of the beaker with the water, subtract out the mass of the water. Okay, got 49.80 grams, pretty close to 50. I used a little pipette to try and measure as close as I could, but hey, human error. And what I'm going to be doing is I'm going to be taking each of these substances, I'm going to light them on fire because I'm a little pyromaniac, and I'm going to hold them like so underneath the beaker and wait until they burn away, and then I'm going to have, see, I tied my hair back this time because I've singed my hair in experiments before. Got my safety goggles and my gloves just in case. And I'm going to wait for the substance to burn and then measure the final temperature so that I can use this formula since I know the mass, I know the specific heat of water, and I'm just going to need the temperature difference between the final, what it heats up to, minus the initial, and I'll be able to calculate the heat energy in joules, which actually I can then, because the specific heat of water actually, that is, where did my Sharpie go? Okay, that's actually joules per gram degrees Celsius. There we go. So, in temperature, I'm going to be measuring in degrees Celsius, and this is in grams, so that ends up canceling out and giving us our heat energy in joules. But I can convert from joules to calories, and go ahead and compute that out to give us the caloric content. So that's the lab that I'm going to be doing, but I would hate to cut this video short, even though I always make really long videos. I would hate to cut it short without lighting something on fire first, because just fire is fun to watch. So I would hate to tease you like that. I really wish I had the big marshmallows now. Okay, are you ready? I know I'm ready to light something on fire. Okay, so, let's do our marshmallow. That looks pretty fun. Actually, let's spirit like we do in Girl Scouts. Believe it or not, I was once a Girl Scout. Okay, you ready? I always love lighting marshmallows on fire. They always taste the best when they're on fire, too. Woo. Yeah, I should have put it more on the fork. There we go. Okay, so a little percent error. Oh no. I don't think I really got a good test run on that. So what we'll do is we'll make sure we do a different marshmallow, and I'll put it more on the top here so I can truly measure the difference. So you see the process, and I'm going to get to work here. So I'm kicking you out of my lab now because very important scientific discoveries to be making here. I'll see you in my next lab. Peace out.